For this video, we have one exponential equation to solve. You can go ahead and pause the video if you want and try it, and then I'll be back. So generally, when we have an equation that has a fraction, the first thing we want to do is eliminate the fraction. Try to simplify the equation. So let's go ahead and multiply both sides of the equation by e to the x. That's your exponential here. So e to the x all the way to the left times e to the x. Same base, we add the exponents, we get e to the 2x. Multiplying the next one, minus 3 by e to the x. You get 3 e to the x. And then multiplying the right side, e to the x here will cancel. This will give us a 10 here. And you try to see what comes out of this and see if you can rewrite the equation. So let's say e to the 2x minus 3 e to the x. Let's bring this 10 over. We're at negative 10 to both sides. Gives me this equation right here, which might look kind of familiar. If you look at this, as e to the x squared minus 3 e to the x minus 10. So notice if I replace this e to the x by some other variable, say u, I get u squared minus 3u minus 10 is equal to 0. U squared minus 3u minus 10 is equal to 0. So it has a quadratic form. So that tells me that I can solve this by factoring, or if it doesn't factor, I can use the quadratic formula. Now I'm not going to use the u substitution. I'm just going to treat this e to the x like it were an x by itself. And I'm going to try to factor this out and say, well, this is going to factor into e to the x. Factors of 10, minus 5, minus 2. And you can switch the signs, but it looks like it'll work if I write it e to the x minus 5 and e to the x plus 2. So basically I have a quadratic in the variable e to the x, and I have one side 0. And we can check this out. E to the x times e to the x does give me the e to the 2x. 2 times the minus 5 is the minus 10, and then the inner terms here, and the outer terms minus 5 times e to the x minus 5 e to the x, and 2 times e to the x, add those up, we get minus 3, so it checks out. Now the other thing about it is, once I have a product equal to 0, that means either one of the factors is 0, or they're both 0. So I simply set each factor equal to 0. One or the other or both have to be 0 in order for this to be true. So I write this as e to the x minus 5 is equal to 0. And then the other one should be e to the x plus 2 is equal to 0. Remember, e here is your exponential, which is approximately 2.71, and so it's a positive number. So then I just solve this first one for e to the x, add 5 to both sides, I get e to the x is equal to 5. Add negative 2 to both sides, I get e to the x is equal to negative 2. So just like a quadratic equation, I get 2 possible solutions. But the last one, e to the x equal to negative 2, that's not going to have a solution, because since e is approximately 2.71, it's a positive number. So you take a positive number to any power, whether the power is positive or negative, it's going to come out positive. So there's no way this exponential can be a negative. So this part, this equation here, has no solution. This one over here, e to the x is equal to 5. I take the log to both sides. And since the base is c, I'm going to use the natural log. Natural log of e to the x is equal to the natural log of 5. And of course, because this is the natural log, the base here is e. So I have the natural log of e to the x, and this is base e right here. Understood. I'll put it in. This is e. So by that definition for logs, we know that the left side has to be x. And of course the right side is the natural log of 5. Now, it did ask for the exact solution. So this is it. X equal to the natural log of 5. Now, if they want an approximation, you can go ahead and use your calculator and take the natural log of 5 and then round it off to 2 places, 3 places, whatever they tell you. But here they want the exact solution. So that's it. Thanks for watching. We'll see you next time.